Identify the function f of x equal to sum at n go from 0 to infinity of negative 1 to the n, x to the 2n plus 1 over 2n plus 1, which is x minus x cubed over 3 plus x to the 5th over 5 minus so on, for x strictly between negative 1 and 1. We notice that the power is 2n minus 1 and the denominator is 2n minus 1. And so observe that this is an antiderivative of x to the 2n using the power rule. Keep in mind that this is an alternating series. So we suspect that f of x is the antiderivative of f prime of x, where f prime of x is 1 minus x squared plus x to the 4th minus x to the 6th. This is the geometric series with the ratio negative x squared. It is convergent as long as negative 1 is less than x less than 1. And when it converges, it is 1 over 1 minus r, which is 1 over 1 plus x squared. So we find the antiderivative of f prime of x. We get tangent inverse of x. The antiderivative of 1 over 1 plus x squared is tangent inverse of x plus c. We also integrate term by term. The antiderivative of 1 is x. The antiderivative of x squared is 1/3 x cubed. The antiderivative of x to the 4th is 1/5 x to the 5th, and so on, plus c. This is an infinite series, alternating. X to the odd integers 2n plus 1. The denominator is also 2n plus 1. Don't forget to add a constant c when we find the antiderivative. It is true that when x equals to 0, f of 0 is 0. So we plug 0 into the function f of x to get c equals 0. Because 0 plus c equals 0. So c is 0. And so the series x minus x cubed over 3 plus x to the 5th over 5 minus so on is the sum at n go from 0 to infinity, alternating x to the 2n plus 1 over 2n plus 1, and this is tangent inverse of x. Since the radius of conversion of f prime of x is r equals 1, the radius of conversion of f of x is also r equals 1, because this is a power series. And so we guarantee that this series converges between negative 1 and 1. But we still need to check the endpoints. When x equals negative 1, plug x equals negative 1 into the series. Simplifying this, we have the sum at n go from 0 to infinity of negative 1 to the n over 2n plus 1 times negative 1 to 1. But this is negative 1 to the n plus 1 over 2n plus 1. It is an alternating series. A quick check will tell us that it is convergent. When x equals 1, we plug 1 into the series, simplifying to get the series n go from 0 to infinity, negative 1 to the n over 2n plus 1. This is also an alternating series, and we will see that it is convergent. So the series is convergent for any x between negative 1 and 1. It is also convergent at x equals negative 1 and x equals 1. We say that the interval of conversion is the closed interval negative 1 to 1, negative 1 less than or equals to x, less than or equals to 1. To summarize, we can express tangent inverse as an infinite series, negative 1 to the n minus 1 times x to the 2n minus 1 over 2n minus 1. And it is x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7 over 7 plus and so on. Now, since we know the tangent inverse of 1 is pi over 4, we plug 1 into x, and we see that tangent inverse of 1 is 1 minus 1/3 plus 1 over 5 minus 1 over 7 plus ... But this sum is pi over 4. So pi over 4 is a number that is expressed as an infinite series. Pi over 4 equals 1 minus 1/3 plus 1 over 5 minus 1 over 7 plus ...